Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, as from the past two sessions, we are discussing about the gradation of physical property, where we have already discussed about the two subcategories, that is physical state and the luster property. So today in this session, we shall learn about the malleability property and the variation of malleability property in the modern periodic table with respect to groups and periods. So friends, let's start with the session and understand the malleability property and the variation of malleability property in details. What is malleability? Friends, if you look around you must have seen some aluminum foils used in your kitchens. You also must have seen some silver foils used on many sweets. Also some gold sheets used by jewelers for preparing jewelries. Not these, or if you have seen some iron sheets used in the building construction. So by what property these elements and how these elements are converted and used in the form of sheets? The answer is malleability property. So the malleability property is a physical property of element that defines the ability to be hammered, pressed, or rolled into thin sheets without breaking. In terms chemistry, when we talk about the elements, we always talk about two main categories, that is metals and non-metals. Are the metals malleable? Yes, metals are malleable. As the malleability in metals occurs because of the metallic bond that keeps the atom in place, and the metallic bonds, which are characterized by the sea of electrons that easily move from atom to another, allows the metal atom to slide past each other if a force is applied. A force can be a blow of a hammer, or the impact from the fall, high pressure from being squeezed, or from a collision. Here are some metal examples which can be converted into thin sheets. These are silver, tungsten, zinc, mercury, aluminum, lead, tin, steel, and copper. So now the basic question arises that why and how the metals are malleable. As a metal are malleable because they are made of a hexagonal and cubic packed structure that can be moved by applying force to them. As when force is applied, the atom in a different plane is slided off to another atom when the force is applied. This is the reason how and why the metals are changed their shapes, since they all things are made of metals are due to the variation in their crystal structure. In other words, as the compression stress force atom to roll over each other into new position without breaking their metallic bonds. And when a large amount of stress is put on a malleable metal, the atom roll over each other and permanently staying in their new positions. So metals have a hexagonal and cubic packed crystal structure. This is the main reason why the metal are malleable. And the second most important factor is the metallic bond between the atoms, as it involved in all the metal atoms in a piece of metal, sharing all their valence electron with a delocalized bond. So the basic two factors which affects the malleability property or the degree of malleability are metallic bond and the temperature. As the nature of metallic bond can influence the ability of metal atom to rearrange themselves. Stronger the metallic bond means that the greater energy is required to move the metal atom into different alignments. Weaker metallic bond means the metal atom requires less energy to shift the positions and By this result, the metal is much more malleable. The second most important factor is the temperature, as the temperature of metal is another important factor that affects the malleability. For example, steel at the room temperature is not very malleable at all, and when heated to the higher temperatures, say when a blacksmith is making a horseshoe, the steel becomes much more malleable and can be beaten with a hammer to form a horseshoe. So these are the two basic and very important factors which affects the malleability property of a metal. So now let's come to the modern periodic table. We know the arrangement of metals to non-metals. That is, when we move from left to right, we move from metals to non-metals, and when we move from top to bottom in a group, we move from lower metallic property to the higher metallic property. So by this, we can conclude the gradation of variation of these property. That is, when we move in a group from top to bottom, we know that the metallic character increases. So the malleability property also increases. And when we move from left to right in a period, we know that metallic character decreases. So the malleability property of element decreases, right? So we can conclude that the sodium have the lesser malleability property than the francium, or we can say that the zinc is less malleable with respect to potassium, right? So here we conclude the session with the malleability property. First conclusion we make is the malleability is a physical property of element that defines the ability to be hammered, pressed, rolled into thin sheets without breaking. Second is the metals are malleable. The malleability is affected by two main factors, that is metallic bond and the temperature. We also discussed that the metals are malleable due to the crystalline structure and the metallic bond. And also we conclude that the non-metals are the non-malleable elements due to the arrangement of atoms. As the way the atoms are arranged, and if solids, they are brittle, that is, they break or shatter on hammering. For example, coal, sulfur, phosphorus are very brittle in nature. So friends, the next session we shall discuss is the ductility. Thank you for watching Edupedia World videos.